dynamic typing, built-in data structures, powerful libraries, frameworks, and community support. These are just some of the reasons which make Python an attractive language for rapidly developing any sort of applications. The advent of AI and ML have only added to the repertoire of this programming language. Hi, I welcome you all to this Python programming session. And what follows is hopefully a complete crash course consisting of everything you need to know to get started with the language. But before we begin, let's look at our agenda for today. So we're going to start out by introducing you to Python. We're going to talk about why is this language necessary, what does this language consist of, what are its main components, so on and so forth. Then we're going to move on to Python operators and its utilities. Our third module discusses Python data types, where we are going to talk about the basic data types that is used in Python. Then we're going to discuss functions in Python. We'll discuss how you can pass data known as parameters into a function and how a function returns your data as a result. Next, we're going to talk about conditional statements in Python and how they perform different computations or actions depending on the evaluation of certain constraints. Module 6 discusses loops in Python. We're going to discuss some basic loops for iterating over a sequence. Moving on, we'll have some intermediate to advanced topics. So Module 7 discusses Python classes and its functionalities. And Module 8 talks about object-oriented programming in Python. Next, we have file handling, which is a crucial part of any web application. And finally, we have some basic, intermediate, and advanced practice programs which will help you get a hands-on experience in Python. With this, I come to the end of my agenda. Meanwhile, kindly take up this time to go ahead and subscribe to us, and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, to learn more about Python and its related concepts, do not forget to visit our Python training program, the link to which is given in the description box below. So without much ado, let's get started.
Hello everyone, this is Wasim from Edureka and I welcome you all to this Python series where we are going to learn Python basics from the very beginning. So I'm going to be sharing exercises in the end of the sessions for practice as well. Now as a complete beginner, what are the things or the difficulties that you are facing while learning Python programming language? Let me guess guys. People keep telling you it's easy, but you find it a little difficult and you don't actually know how to start learning Python. Also, you just need a little guidance and you are lacking a structured learning path. Well, let's start with the simple definition and then we'll install Python to move forward. So what exactly is Python programming language? Python programming language is open source, simple and highly readable programming language with powerful libraries and the many features that makes it easier for not only existing programmers but for also the complete beginners to learn Python in no time. So these are the features that Python actually provides, which is simplicity, being open source, also which makes it, you can think less of a syntax of the language and more of the code. And being open source makes it a powerful language and also makes it free to everyone for use and alter as needed. It is portable, which means Python code can be shared and it would work the same way it was intended to, seamless and hassle-free. Being embeddable and extensible, Python can have snippets of other languages inside it to perform certain functions. And being an interpreted language, the worries of large memory tasks and other heavy CPU tasks are taken care of by the Python itself, leaving you to worry about only the coding part. And Python has you covered with a huge amount of libraries for domains like data science, machine learning, artificial intelligence, web development, you name it and you have a library for it, which makes it easier to implement complex tasks. And last but not least, Python is an object-oriented programming language which helps breaking down complex real-life problems into tasks such that they can be coded and solved to obtain solutions. And now that we actually know what Python is and its many features, let's begin with the installation, guys. So we're gonna have to follow a certain steps to install Python, and don't be intimidated guys, it's a very easy process. You just have to download a few things, and then you have to install it by clicking a few buttons. But the important part is checking the important boxes. So the very first step that you have to follow for installing Python on your system, you have to go to python.org, guys. And here you're going to find the download section where you can download the Python implementation for your system. So here you can just download the latest release for Windows. Also, you can check out other releases, or the latest Python 3 release is Python 3.8.3, and the latest Python 2 release is Python 2.7.18. Also, these are the stable releases, which is Python 3.8.4 RC1, which is supposed to come out June 30, 2020. And then there is Python 3.7.8, which you can download. Just click on it and you can find a suitable version for you. So I suggest you download this Windows x86-64 executable installer. And after you download, you can just go on to the download section, click on it. It will open a window something like this. Since I have already installed it, it's showing me to modify, repair, or uninstall. So I'm not going to do anything, but I'll just tell you what happens if you go for the next part. It will just install it for you guys, and don't forget to tick the checkbox which says set environment variables, because it's going to set path for your Python environment. And if you forget that, it's going to be a manual process where you have to navigate to the python.exe file, and you're going to have to set it manually, the Python path, which is not a very big task, guys. It's quite easy. You just navigate to the python.exe file in your system and copy the path of the file and paste it in the advanced settings where you will set the environment variable. And now that we are done with this, the very first thing after the installation that you have to do is check for any redundancies or any problems. So for that, just type Python over here. If everything is smooth and went fine, you will see something like this. You will enter the Python shell, and you can, I'll just exit this for now, and you can just check the version of the Python using this command. So just check whichever version that you had installed is already here or not. Now after that, there is the one thing after the installation that every Python programmer, or any programmer for that matter, has to go through. It's like a rite of passage for programmers. So after you install a programming language on your system, guys, what you have to do is perform a certain task, which is the Hello World program. So the Hello World program is the most basic thing you can do with a programming language to know if it actually works or not. So for that, you will just write Hello World using the print statement, and it's as easy as it looks, guys. You don't have to do anything, and since it's Python shell, I can just write it like this also. Alright, guys, so this is how we write the Hello World program in Python. And also there is idle, guys, so which is an integrated development environment which we have with Python. So idle has been bundled with the default implementation of the language, and it basically comes with the installation, but we will use other IDEs available for the Python in other sessions. And now that we are done with the introduction where we have just installed Python, I'll just show you how we can write a Hello World program here as well. So this is how you write a Hello World program, guys. So next up, what I want to talk about is also you can just make a new file, or I'll open a new file, guys. So this is my Hello World file I have made. Also, there is one more parameter that we can add in the print statement, which is end. So by default, it's going to be a new line, which is /n, or you can just add anything you want in the end of the line. So if I run this, the output would look something like this, right? At the end, we have an asterisk value because I have specified it over here. So this is how we run the Hello World program in idle as well. So now what we'll do is we'll go to Jupyter Notebook, guys. So I'm going to use Jupyter Notebook for this session and for other sessions later on. So if you don't have Jupyter Notebook on your system, you can install it. It's a very easy process, guys. You just have to install Anaconda, and using the Anaconda prompt, you can use Jupyter Notebook as well. But if you don't want to do that, you can use Google Colab as well. And Google Colab is nothing but a Jupyter Notebook environment that requires no setup to use and runs entirely in the cloud. So that is one more option that you have, which you can use if you don't want to install Jupyter Notebook on your system, guys. Now to understand variables, think of it as a container to store an entity. And as the name suggests, it can be varied. because variables, which means that it can be varied later on. So I'm gonna just show you how we can use variables, and I'll tell you about few naming conventions that you have to follow while working in Python. So the very first thing that I would do is I would take one variable. Let's say a is my variable. Now to assign a value to this, I'll just simply assign anything, like I am a beginner. So this is how easily I can just declare a variable. There is no statement that I have to follow up to declare a variable or to specify any data type to a variable. Alright guys, if I want to print it, I'll use the print statement, something like this, and I'll share you the Jupyter Notebook cheat sheet so that you can use Jupyter Notebook easily. And let's just say I'll take one more variable. Let's say I want to learn Python. And now when I print A and B, I can do it like this as well. Alright guys. Or if I want to reassign the value to B, let's say, now when I print B, it changes to the value I am learning Python because I have reassigned the value to it. So let's just talk about a few naming conventions related to variables in Python, guys. So the very first thing that comes to my mind is how or what are the names that I can use with variables. So there is a rule in Python that you can only use alphanumeric characters or numbers to start a variable. So I can just write it as 9 alpha, let's say, is equal to so and so. No errors. Okay, we have error here, guys. Alright guys, we have a syntax error which says invalid syntax, so we cannot use a number to start a variable. Can we use a alphanumeric character? No, we cannot. It is a syntax error again. Or can I use let's say another symbol? Okay, can I use an underscore? Yes. So we can use an underscore or a double underscore to declare a variable. We'll talk about this later on in the session when you're talking about the private variables, right? So this is how we declare a variable in Python. It cannot start with a number. It has to start with either a variable name, which is a character, or underscore. Or can we use numbers later on? All right. So we can use numbers later on or any characters, I guess. All right. So we cannot end with this. All right. So we cannot just use all the letters. So there are a few limitations with what we use for naming the variables, and after that I want to talk about how the variables in Python are case sensitive, guys. So if I write b is equal to Python, right, and when I want to print b here, it is still printing I am learning Python because variables in Python are case sensitive. So these are two different variables that I've declared, and to get this value I'll have to use b here. So this is one naming convention that we have with variables, which is variables in Python are case sensitive. All right, guys. So now what we'll do is we'll take a look at a few other things that we can do. All right. So I'll just name a few more variables. Let's say Python. So when I print first and last, the output is somewhat like this. And all right, guys. So now that we have come to the end of the session, what I want to talk about is an exercise for you guys to be prepared for the next session. So for this, the first exercise that you have to do, or the first thing that you have to do in the exercise, is you have to write a program where you have two variables a and b with you, and it can be first and last like this respectively, which will have, for anything you can take the values, and you have to print both the variables n number of times, and n here cannot be less than 3. So if let's say a or first is equal to Python and last is equal to programming, and we are taking n as 3, the output should look like this. And the second exercise that I want to recommend for the next session is, guys, even though you can work with Google Colab, I want you to go through the installation process of Jupyter Notebook and how we can use it. And You'll also get to know about the Python Anaconda, how you can use it for Python development. So do it, guys. I'll add the link to the tutorial where you can just learn how to install Jupyter Notebook. And if you get any errors, you can just mention them in the comment section. And if you are new here, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. Also check out Edureka's Python programming certification program. The link is given in the description box below. So guys, when you complete these exercises, it's going to help you to understand the next part, or it's going to make a necessity where you will know why you want to learn the next session, which is going to be operators in Python. So try to do as much as you can with using only the variables and what I've taught you in this session, so that you'll understand why we use what we use in the next session. And we'll be having exercises like these later on in the other sessions as well. So stay tuned. And since this is the beginning part, we're going to move on to the next topics like data types in Python, operators in Python. We're going to talk about classes and objects. There'll be functions, file handling, OOPS concepts as well. So we're going to learn about how we can do inheritance and polymorphism and other concepts such as, programs to print star patterns and hangman game. And there'll be programs in the end of the session to actually implement whatever we are going to learn in the Python series. This module is going to be about the operators in Python. So if you try to write the program in the last exercise, you must have come across a simple thought. Why can't we just multiply the number of times we want the variables to print? So the good thing is, yes, we can using the operators in Python. So the point of the last exercise was to create a necessity to learn operators. So what exactly are operators in Python, guys? So simply put, they are used for operations between two values. Now, depending upon the kind of operation that needs to be done between two values, there are several types of operators like assignment operators, there'll be arithmetic operators, or there are comparison operators, etc. So let's take it up to Jupyter Notebook, guys, and we'll see how operators actually work in Python, guys. So the very first thing that we would do is, okay, let's just give it a heading, operators in Python. All right, so we know for sure that operator in Python is going to deal with two values. So first of all, we are going to talk about the assignment operators, guys. So as the name suggests, assignment operators are actually used to assign values to, anything. It could be an object, a class, or anything, any object in Python. If you want to assign a value to any object in Python, we're going to use the assignment operators. So what are the various types of assignment operators that we have in Python? All right, guys, let's say we have a variable x and we want to assign a value, let's say 10. So this is a simple assignment operator where we have assigned a value to a variable, guys. So then we have the arithmetic operators, guys, which are used for arithmetic operations like addition, subtraction, multiplication. There is division, exponentiation, floor division, right? So the value of x is 10 over here, guys. So if I add 10 to x now and print the value of x, it becomes 20, guys. So instead of writing x plus 10, I can just simply write it as plus is equal to, or for subtraction I can write it as minus is equal to, and then for other similar operators I can write it like that as well. So this is the simple assignment operators, guys. So similarly we'll have minus is equal to, and then we'll have multiplication is equal to, or exponentiation is equal to, or there'll be floor division is equal to, something like that. So these are the assignment operators that we have in Python, guys. So I'll just remove this, guys. So next up we have arithmetic operators, guys. Let's take two variables, guys. So we'll take x is equal to, reassign the value because we can reassign the values to variables in Python. So we'll take it as 15, and y we will take it as, let's say, 3. Okay. So arithmetic operators are used for arithmetic operations such as addition, multiplication, division, etc. Right, guys. So first operation that we want to do is we'll do addition. We'll do x plus y, right? After that we can do x minus y, and then we can do x multiplied by y, or x division by y. So as you can see guys, you are seeing a float number over here, which I'll talk about when we're talking about the data types in the next session. And to remove this decimal point value from this, we can use the float division guys. All right, so for that we'll just write it like this. And this is the float division guys, which does not have any decimal point values in the output. And after that we have the exponentiation, and if we do that we'll get the value as 3375 because we are doing the 15 to the power 3. So that's why we're getting this value. Or we can change the value again, let's say 5, to make it more relatable guys. So when we do this now, it will be 125 because 5 to the power 3 is 125. So these are the arithmetic operators that we have in Python guys. So next up I'm going to talk about the comparison operators. So comparison operators, as the name suggests, are used to compare two values guys. So how can you compare two values? They can be either greater, smaller, equal to, not equal to. And that is how we use the comparison operators. So we have greater than, less than, greater than equal to, less than equal to, and then there is equal to and not is equal to. So let's say we have two variables again, x is equal to 10 and y is equal to 15, right? And let's say z is equal to 10 again. All right. So now what we can do is we can make statements guys. So let's say x is equal to z, right? That is true because x is actually equal to true. Repeat, because x is equal to z, that's why it's giving the value as true. If I do this, it'll make it false because it's not equal to x. So the next operation would be x is not equal to z. So when I check this, it will be false, or if I write y over here, it will be true. And then there will be x. All right, so we'll just greater than y, false. X less than y, true. And then there is greater than and equal to. So for this, I'll write z over here. It is true because x is not greater than z, but it is actually equal to z. That's why we're getting true. If I write it as y, it will get false. So if I write it as less than or equal to y, it will give me the value as true because it is actually less than y. So these are the comparison operators that we have in Python guys. So these are all the operators that we use to compare two values, and these are the values, or these are the statements that we'll use in the conditional statements. So the comparison operators actually help a lot when we are working with the if statements or the else statements, because there we have to specify a condition. If that is true, we'll move on to the next block. Right, so we'll do that later on in the other sessions. So next up we have the logical operators guys. So logical operators are nothing but the logical and, or, and not. So for logical and operator, both the statement has to be true for it to be true. If either of them is false, the output will be false. And for logical or operator, either of the two statements, if it is true, the output will be true as well. So let's just try to understand this with an example. So for this x, y, and z, what we'll do is let's say x is greater than z and x is also, let's say, less than y. So when I run this, the output is false because x is greater than z. It's not. X is greater than or equal to z. Now it's true because both the statements are true. And if I write it like this, it is actually true, and we make it greater than. Now it's false because one of the statements is false. So for a logical and operator, both the statements has to be true in order to be true in the output as well. Similarly, for logical or operator, either of the two statements, if it is true, it will be true. So it has to be, both the statement has to be false. So we'll just say is equal to z or not is equal to z. All right, so we'll x is greater than. All right, so we were getting that output because we were getting that error because there was this assignment error guys. We cannot just assign a value in two operators. We can just compare these values in these statements, right? So this is how we check, or if we could have done something like this. Now it won't show any errors, right? And if we do it like this, we'll still get a syntax error. So this is false because both the statements are false here. X is neither greater than z and x is not equal to 0. Repeat, x is not equal to y. So that is how we use the logical and or operators. There is one more operator, which is logical not operator. So now that we are getting the value as false, if we use the not operator, it is basically going to negate this output and make it true. So that's what the logical not operator does. And now that we are done with the logical operators, we have the identity and membership operators that I'm going to talk about. So identity operators and membership operators are basically used when we are, I mean, you'll be able to understand these operators better when we are working on other data types such as list and dictionaries, or working on loops in Python. So for identity operators in Python, they are basically used to compare two objects. All right, so it's going to return true if both the objects are same, or it's going to return false if it's not. So there are two identity operators, which is basically is and is not. So let's say we take two variables. First of all, we're going to take strings only, and let's say the first one is Python and b is equal to programming. We don't have to worry about the previously declared variables because we can reassign the values, right? So if I check a is b, it is false because they're not the same object, guys. And if I write a is not b, it will be true because these are not the same objects. And to understand this better, I'll just take one example to make it clear to you guys. So let's say I have a is equal to, right, and b is equal to. Now I have two lists over here. So if I check a is b, it is false again. So now to make it true, what I'll do is I'll take one more variable, and this particular object or variable going to be same as a. So now if I check a is c, value is true because they are the same objects. And if I check a is not c, then it will be false because they are not the, I mean, it's the opposite of being not an object. So basically the identity operators are used to check or to compare if the two values or the variables are same objects or not. Similarly, we have membership operators, which is basically in or not in. So since we have an iterable over here, which I'll explain later on in the sessions, guys, this is just to explain it to you guys. So these are two lists. So what I'll do is I'll just check. All right, so we'll take one more variable is equal to 10. Now what I'll do is we'll check if x in a, right, it's true because it is there actually. And if I check in b, it will be false because 10 is not there in b. And similarly for not in a, all right, and not in b, true. So that is how you use the membership operators in Python, guys. So I think it's quite simple to understand the difference between all these operators. And last but not the least, we have the bitwise operators, guys. Now the bitwise operators are mainly used to compare binary values, guys. So let's just say we have x is equal to 10 and y is equal to, let's say, 12. So in reality, what 10 in binary would be, it would be 1010, and subsequently 12 would be 1100, I guess. Yes. So we'll comment out this part. Also, I'll just tell you about comments, how we can use them. You can just mention something like this, and there's a comment, guys. Or there are doc strings as well, where you can just type anything and they'll be treated as strings. So this is a comment, guys. So that is how we use comments in Python. So now if I want to compare these two values, so let's say if I want to use the AND operator or bitwise AND operator. So this is the bitwise AND operator. So now what will happen is it will compare both the values. So, and if both the bits are true, it will return true, which is 1. So if both the bits are 1, it will return 1. If both the bits are 0, it will return 0, right? So it has returned 8. So the subsequent or the equivalent of 8 in binary is 1000, and there is only one instance in this statement where both the bits are 1, which is the rightmost bit. So that's why we have the answer as, or the output as, 8. Similarly, we have the bitwise OR operator, and this will return true or return 1 if one of the bits is 1, and then we have the bitwise XOR. So a bitwise XOR operator would change the bits to 1 if one of the bits is 1. So in this case, we have two instances where one of the bits is 1, so it will change to 1, and the subsequent number will become 0, 1, 1, 0. So that's why we have the output as 6. And then we have left shift and right shift, guys. So let's say we want to left shift X to 2 digits. So what will happen is the output will become, so right now it is 1010. Now what will happen is it will add 2 zeros from the right and shift left. So now the number will become 40. And if we do the right shift, it has become 2, because what will happen is this last number will shift 2 points here and add 0, 0, 1, 0, 0, 0. So that is how we are getting the value as 2, and it's going to drop these rightmost digits and the value will become 0, 0, 1, 0. So that is how we are getting this output as 2, and that is all about the bitwise operators, guys. With this, we have come to the end of the session, and if you are new here, guys, don't forget to subscribe to Edureka for more exciting tutorials and press the bell icon to get the latest updates on Edureka. And since we're done with this session, I'm gonna give you a few exercise questions to do before the next session. So the first one is, you have to write a program to calculate the factorial of a number n. So if you want to find a factorial of number 2, you have to do 2 multiplied by 1. So that is the 2 factorial, and for this exercise n cannot be less than 5. And the next exercise that I want you to do is, you have to write a program to calculate the value of 2 to the power 1295. This module is going to be about various data types in Python, and this is the module 3 of the Python series, guys. And if you did the last exercise, guys, you must have come across an error, which is a type error. So I'll just tell you in this session how we can work with the different data types in Python. So without any further ado, let's begin our session. So what exactly are data types in Python, guys? Now, I've already told you how variables are used to hold values for different data types. So as Python is dynamically typed language, you don't need to define the type of the variable while declaring it. You can just simply assign a value to a variable, and the interpreter implicitly binds the value with its type. And to check the type, we can use the type function. So in this session, we'll stick to the basics, guys. I'll add the detailed tutorials for the data types so that you can follow up later. So let's take it up to Jupyter Notebook, guys, and we'll start with the first data type. So right now, okay, we have an invalid syntax. So we'll give it a heading first of all. Let's call it as data types in Python. All right. So the first data type is numbers, guys. So now you must be wondering, what are numbers? So basically any number that you define, it could be an integer, it could be any decimal point value. That is the numbers data type. All right. So let's say if I have a variable a and I'm giving the value 10. So this is an integer. And to check its type, I'll just write the type function, which is a built-in function, guys. I'll pass a as an argument. We'll learn about this while working on the functions. So don't worry, guys. It just tell you how to check the type of your variable. And it's showing that it is an integer data type. So if let's just say I add a few decimal point values to it, now the type will change to float. And if I add an imaginary value, let's just say this, all right, so the type will become complex. And similarly, there is one more data type, or there is one more type of numbers data type, which is Boolean, guys. So for Boolean data type, what we'll do is we'll take a comparison operator, guys. So let's just say 10 is greater than 5. So there's a statement now. Now if I want to check the type of this, it will show me that it's a Boolean, all right. And if I execute this, I will have the output as either true or false. So if 10 is greater than 5, it will give me the value as true, or if 10 is less than 5, it will give me the value as false. So that is all about the numbers data type that we have in Python, guys. Next up, we have the strings data type, guys. So strings are nothing but, the values or the character values that you declare inside a variable using the double quotes, single quotes, and there are triple quotes as well, which is doc string. I'll tell you about that. So let's just say I have a variable name and I want to declare some value, let's say Python. And when I check the type, it will show me that it's a string data type. All right, guys. So what are the properties of a string? Strings are immutable in nature, which means you cannot modify a string. All right. So even if you can perform operations like concatenation, joining two strings or replacing some value, let's just try to do that. Okay. So, and to access the value or any value in a string, we use indexing, guys. So for indexing, I'll just tell you. So let's say if we have these right, six characters in a string, the index value at n, or the index value will start from p, which will be 0, and will go until n. So if the length of the string is 6, the index will end at 6 minus 1 because it starts from 0. And we have negative indexing as well. So at n it will be minus 1, the index value, and at p it will be minus 5. Right, guys? So to access a string, let's say I want to access the last string, which will be 6 minus 1, right, 5. So it is giving me as Python. All right. So if I do this, I'll get this, or like this, I'll get the character at the, or the string at the index number 0. So let's say if I want to reassign this value, because in Python we can reassign values, right? So if I want to change the value at 0, instead of p, I want to make it as, let's say, small case p. It's a type error, guys, which says string object does not support item assignment. All right. And one more thing, the error that I was talking about. So let's say if I want to append or insert or concatenate a string with an integer which is a, we have a type error again, and this is the error that I was talking about in the beginning that you must have faced while working on the last exercise. So it can only concatenate string to string, right? So for this, to resolve this, we'll just use the string constructor, and this is how we do it. And this is just a simple example, guys. So what I was talking about is the immutable nature of string. So even though it's immutable, we can still perform operations on this because every object that we get after the modification of the string will be a new string. So we won't be making any changes to this string because it's immutable. Instead, we'll get another string, a new string, which will have the modified value. All right, guys. So that is all about strings for now. And we'll talk about the slicing and dicing in the end of the session. So the next up we have is lists in Python, guys. So before moving on with the list, if we talk about the different operations that we can perform with strings, let's say we have name is equal to Python and last is equal to, let's say, programming. All right. So we can write it, or we can concatenate these strings. And there are other methods that you can use to perform operations on a string, and I'll just add a detailed tutorial of Python strings in the description box so that you can follow up later. Next up, we'll talk about lists in Python, guys. So lists in Python is a collection data type which is used to store multiple values. It is ordered, it is mutable, which means we can change the values or modify the values, and we can use the indexing to access the values. So to declare a list, we will simply have to write it as inside the square brackets any element, or these elements that I'm talking about can be any data type. It could be a range function, it could be any other function, it could be a tuple, it could be a set, it could be a dictionary, or simple integer and strings as well. It could be any other data type that you want. So we'll stick to integers for now. So let's say we have all these numbers. So I have declared my list. So when I call my list, so this is the output that I'm getting. All right. So there are several other list methods that we can use, like insert. There is insert. So inside which we will just have to specify the index number, and it will add the element that we want over there. So let's say, and now when I check my list, there is an element inserted at the 0 index value, and it could be inserted anywhere we want. And Similar to insert, we have append, we have extend method. There are a lot of methods that we can use with a list, and I'll add the detailed tutorial for list so that you can follow up later on the list methods as well. To give you a perspective, let's just say we want to access a value starting from the 0th index. Now this is where slicing comes from. We can slice the objects or the data types to access certain elements from an object. So since it's an iterable object, I'm gonna get the values from 0 index until 5. So these are the values that I'm gonna get, right? And using the negative indexing, let's say how much I can. So we'll start with -1 and go until -5. It's a empty list because back propagation is not allowed inside a list. So I can only go from -5 to -1. So this is how indexing works in Python, guys. So let's just talk about other list methods that we have. So let's just, so these are append, clear, copy, there is count, extend, there is index, insert, pop, remove, and reverse. So let's see if I want to use reverse, what exactly happens. Now my list is reversed, guys. So to reverse my list, I'm going to use the reverse method. And let's just say what all other methods do I have. There is append, right? So I'm going to append the value, let's say 12. Let's see what happens, right? My list. So I have appended the value at the end of the list. So if you use append method, it's going to insert the value at the end of the list. And let's just see one more method, right? So we'll check for all, we'll pop element. So we have popped 12, which is the end element. So now let me just use another method, which is remove, where I can just specify the element that I want to remove from my list. So I'll just write as 10. So it's going to remove the element 10 from the list. So as you can see, we have the same list again, and if I use the reverse method again, my list is back to the original list. So this is how we can use list to our advantage, and we can use nested lists as well. There is nested dictionaries as well we can use. So talking about dictionaries, dictionary is another data type that we have in Python, guys. It is a collection data type. It is it is declared using curly brackets in the pair of key value pairs. So for each key there will be one value, and these key value pairs are treated as elements in the dictionary. So that is how you declare a dictionary, guys. And to access a value in a dictionary, I can just simply call the get method, and over here I can just provide the key value, and it will fetch me the value at the particular key. Alright, guys, so talking about the properties of a dictionary, it is in key value pairs. It is let's see if it's changeable or not. So we'll try to change a value. So instead of 1, let's say we want it to be 3. Are we able to do that? So if I want to get the value now, the value is 3. So I'm able to change the value or update the value. So it's not immutable in nature. We can change the values or reassign the values. And for list also we can reassign the values, guys. So let's say if I want to reassign the value at 0, so instead of 1, I want it to be, let's say, 100. And now when I print my list, the value is changed to 100. So that is the advantage with these data types. Also, we can use any data types in the key value pairs. It could be an integer, a float value, or it could be a string, list. We can do anything. We can make a nested dictionaries as well. So dictionary actually helps in making an exclusive entry for each keys, because keys can never be duplicated, guys. Keys has to be different from one another. So let's say if I change this to 1, right, let's see what happens. It's only showing me one pair where I have actually declared 2, because there is no exclusivity in the keys. Alright, guys, so let's just check the methods that we have with dictionary. So we have clear, we have copy, and we have from keys, we have pop item, set default, update, and values. So these are the methods that we can use inside dictionary, guys. Alright, guys, let's start with a few dictionary methods. So let's just check the values. So it is showing us the values inside a tuple, and inside the tuple we have a list with the values. All right, so let's just check for keys. So these are the keys that we have. We have checked for keys and values, and let's just try to. Right, we have an error. Pop is expecting at least one argument, so I'll just write 2. So let's just add one element, update it, and print it now. So we have two values, 1 and 4. So that is all about these methods that we have in dictionary, guys. And next up we have a tuple, guys. So a tuple is declared using round brackets. You can just mention any values, but it is not changeable, which means it is also immutable, guys. And it only has two methods, guys, which is count and index. So you can just count the elements, number of elements it has. So 7 is 2 times, so I can count the value, or I can get the index value for 7, which is 5, and it's going to show me 5 because it's going to show me the index of the first element that it encounters. Also, duplicate values are allowed in a tuple, guys. So that is one property that we have. And next up we have sets, guys. So sets in Python are declared using round brackets, and you can mention any values, guys. Let's say but even though it's not showing any errors, the duplicate values are not allowed inside a set, and there are several operations that you can perform on a set. So we have add, clear, copy, difference, update, discard, intersection, disjoint, subset, superset, pop, remove, etc. So all these methods that you can use on sets in Python, guys. So I'll just add a link in the description for all the detailed tutorials about these data types in Python. And last but not the least, we have a range function, guys. It is considered as a data type in Python, guys, but it's sort of a function. So range is basically, I'll just tell you guys. So range of 0 to 10, right? So A is equal to a list of range 0 to 10. So when I print A, I have these numbers, which is 0 to 10. All right. So this here, right here, is a list constructor. Similarly, we have for each data type. For string, it is a string. For integer, it is int, and for dictionary, it is this. For tuple, it's a tuple, and for set is a set. So these are the constructors that you can use to declare a tuple, set, a dictionary, or any integer or string data type, or to convert one data type into another. And range is just giving you a set of numbers that you can use or put inside an iterable object, which is a list. It could be any iterable object that you want. It could be a dictionary, or a set as well. And one more thing about set, guys, to access any values from a set, you can also use indexing, guys, because set object does not support indexing. It is unordered. So that is one drawback we have with sets. And coming back to range, guys, so I can have any values inside a range. And there is one more thing that I want to talk about is there is a step that you can mention over here, which is let's see, it could be a negative step, it could be a positive step, or anything. So when I print A now, it has only the value 0, 2, 4, 8, and 6, because there is a step of 2 here. So the first element will be 2, and after that it takes 2 steps and goes to second. So the second element is after 2 steps, which is 1 is skipped, the next one is 2. So if I write 3 over here, it would be something like this. So if I make the range from 100 to 10 and make the step as, let's say, 10, the values would change drastically. And since back propagation is not available, it could not take a forward step, it has to take a negative step. So that is how we use range function in Python. This is a very basic example that I've shown you, guys. And since we are done with the data types in Python, I'm going to show you a small exercise that you can do to make sure that whatever you have learned is put to good use. So I want you to write a nested dictionary program in Python where you make use of at least two dictionaries nested inside the main dictionary. So what I want you to do is make one dictionary, right? So instead of key value pairs, the first key should be a dictionary. After that, the value, right guys, wait a second. After that, there'll be value. Then again, you will, the next element would be a dictionary and this will be a value. And for each dictionary inside the dictionary, I want you to take different data types. So for the first one, I want you to take a string, and the next one I want you to take a tuple. For values, you can use any data type that you want. Alright guys, and each dictionary should have at least 3 elements or 3 key value pairs. So that is one exercise that I want you to do. And the other exercise that I want is to write a program to reverse a list in Python without using the reverse method. Alright, I want you to use the slicing that I've told you, or the negative indexing, and try to make use of it and reverse a list in Python consisting values or the elements from 0 to 10 using the range function. And I want you to write a program for list of dictionaries. So the output should be a list consisting of dictionaries as elements, and each dictionary must have at least 2 key value pairs with different data types. Functions in Python. And this is the module 4 of the Python series, guys. Now to understand what exactly are Python functions, let's consider the program to find the factorial. So to find out the factorial of a number, we will write the code. I mean, whatever logic we have for finding out the factorial, we write that code. Now, if somebody asks us to find the factorial again, we will have to look back for the same program again, and then again, we will run it to find the factorial. Now, let's say if we want to keep checking the factorial of a number again and again and again, it will become a very tiresome task for us to go back to the program, run it again and again and again. So what could be done for this problem? We can make a function which is basically a bundle of the logic that you can put inside a block, and each time you want to execute that particular logic, you just call the function and your job will be done. So that is like importing a function into your program and using just one single command to execute your task. Now since I'm talking about the factorial of a number, it may sound easy, but imagine a complex task where you have certain dependencies and there are a lot of things that you have to consider. Then if you want to write the program again and again, it will become a very tiresome and non-efficient task for you. So that's why we use functions in Python. Now, to have a wider perspective on what goes on while writing a function or how to declare it and how to call the function, let's go to Jupyter Notebook and we'll try to understand how we work with the functions in Python, guys. So let's just give it one heading. First of all, we'll write it as Python functions, right? So the very first thing that you want to see is how we declare the functions in Python. Declare function, which you have to write def, that is def, and after that you have to write the name of your function, which could be anything, guys. You just have to make sure that these are the unique names that you're using for your function. And after that, there comes the indentation block where you have to specify the logic of your function. So for starters, let's just write a print statement. So this is my function. All right. So I have made my function, guys. So now to call my function, I'll just write function over here, call it, and it will print this is my function statement that I have inside my function. All right. So this is how simple you can just create a function, use it to call it, and whatever value that you have saved or the logic that you have inside your function will be executed in that block. Simple, guys. It sounds very easy, but there are certain things or certain built-in functions like we did with type. Type is a built-in function. Then there is a map function, there is filter functions and reduce functions that I'll just add those links in the description box below so that you will be able to understand those better in detail. But for now, I just want you to get an idea of what function actually is. So there are two types of functions that we have in Python. There'll be inbuilt functions or there'll be user defined functions. And there is another way to write functions in Python, that is lambda functions. So first let me just talk about lambda functions in Python, guys. So what exactly are lambda functions in Python, guys? Lambda functions are anonymous functions which are actually defined without name. So let's just say I'll just call x over here, and what I have to do is I'll just write lambda, and after that I write my expression. So I'll write x, y, and this is going to be the operation or whatever logic that I want inside my function. All right. So let's just say I want exponentiation of x and y. So now when I call x, I'll give the parameters as, let's say, 10 and 2, and it will give me the value as 100 because the operation is x exponentiation y. Or I can do this, which will be 20, or I can define the logic as this, which will become 12. I hope you're getting my point, guys. So this is one example of how we define a function in Python, which is a lambda function. Similarly, we can define other logic as well. Let's say x is equal to lambda, and we have x over here. So instead of using an expression, I can just call another function. Let me just call another function, guys. All right. Is there any errors? No. So when I call x now, and I have to give a one parameter, I guess. All right, missing one parameter. All right. So if I remove x over here, so simply using the lambda function, I'm able to call my other function that I've defined over here. Calling function from a function, it's quite easy with Python, guys. So now let me just talk about the recursive functions that we have in Python. Recursive functions are nothing but those functions which call itself, and it kind of creates a loop until you provide a end statement, which actually involves a lot of conditional statements and control statements where you'll be using if and else statements. So I'll just quickly tell you an example for your understanding. So let's just say we have a function, and I'm going to be using a conditional statements, but don't worry, guys, we'll have a separate session for conditional statements, so you'll be fine. So let's say we have a function in which we are going to print, let's say this is a recursive function. All right, so now I'll give it one parameter, let's say num, which will be a number, and with each iteration it will be -1. So if it's 5, then it'll become 4, and after that, if number is equal to 0, we will return done, else we are going to return the same function, guys. And when I call the function now, give it a value, let's say 5, so it's going to print this is a recursive function 5 times, and after that it's showing done. I'll explain how we are using the control statements in the later on session that we have on conditional statements, but to tell you the logic behind this is this function is calling itself inside the function. So that is how we create a recursive function in Python, mostly used for a substitute for where you want to loop through a program, but it's not recommended because it has a lot of disadvantages as well. Among a lot of advantages, there are a slight chance of mismanagement, and if you don't create or don't provide this statement where you are creating end statement for the recursive function, it will just go on forever and it will eat up a lot of memory on your system. So now that we are done with the recursive functions as well, so let's just make a bunch of functions that we'll use to create or to do some arithmetic operations, right? So we'll return x plus y for this, and we'll define, let's say, subtract a and b, and return a minus b. Similarly, all right, so subtraction is there, we have multiplication, all right, and we'll have division. Let's add floor division. and we'll add exponentiation as well. So all these functions are there. Now what I'll do is I'll make a call for all these functions, right? So add, let's see what happens. There is 2 arguments missing, so let's just make 2 variables. X is equal to 10 and y is equal to 12, and we'll pass x and y here. Similarly, we'll call the multiplication operator. Alright, so we can have exponentiation as well. Then we can have a floor division. Okay, and after that we have division. So this is how you can create a lot of functions for your calculator. Also, you can create a calculator app, but for that you'll have to make use of a class. This is how we can create a bunch of functions for various tasks that we want to perform in any program. And now that we are done with this program as well, I just want to create one more function. And this function is going to be very simple, guys. I'm going to make a factorial of a number. Alright, so I'm going to use a recursive function in this. So let's say I define a function and number here. So if that number is equal to 0, I will return the number, else I am going to return number multiplied by function of number minus 1. And let's call our function. Wait a second, guys. Alright, so this is how you create a function to calculate the factorial of a number. It's quite easy, guys. Every time you just want to calculate the factorial of a number, you just provide number here and it will give you the factorial of that number. So that is one advantage that we have with functions. And now that we have come to the end of the session, guys, I want to give you an exercise for the next session, which is nothing but I want you to write a program where you declare a function to get the Fibonacci series in Python. And if you don't know, guys, Fibonacci series is nothing but a series where each element is the sum of last 2 elements. And then I want you to write a function to calculate the sum, subtraction, multiplication and division of 2 numbers that I've already done, but I want you to create it in such a way that it looks better, and I want you to add more functionalities instead of just these addition, subtraction, multiplication functionalities. I want you to add operations like checking if the number is greater or not, or checking if the value is a prime number or not. Let's talk about what are the conditional statements that we have in Python, guys. So conditional statements are nothing but statements that have a certain condition, and only when the condition is met, the flow of the execution enters its block. Now to understand this logic, imagine you're going to enter inside a building. So the condition to enter inside the building is if you have an ID card. So if you have an ID card, you can enter the premises. If you don't, you are not allowed to go inside the premises. Either you have to leave or go to someplace else. So that is how the logic works in conditional statements. So in Python, we have if statement and we have else, and we have if else as well, which is known as elif statement in Python. So let's just go to Jupyter Notebook, and I'll give the heading over here as conditional statements in Python. Alright, guys. So for this, I'm going to explain what is if statement, what is else, and what is elif statement. So right now, let's just talk about the if statement, guys. Alright. So if statement is nothing but a statement which will have a prerequisite, like a condition that has to be true. Only then execution will enter its block. So let's say the condition is, or let's say I have one variable, let give the value, let's say 10. So if x is greater than or let's say equal to 5, So this right here is one condition. Until or unless it's true, the execution will not move from here. So if it's true, we want to print it is greater. All right. So I think you understand, guys. That's how it works. If the condition is true, the print statement is executed. So what if the condition is false now? Okay, we have no output for this because the penultimate statement for this will be in the else statement, right? So when I say the penultimate statement or the alternative, so when x is equal to 10, the execution moves towards the block. So if x is not equal to 15 or not is equal to greater than 15, it will move to the next block, which is the else block. Here it will print whatever it is in the block of the else statement. And the syntax is pretty clear, guys. You use the if keyword, after that there comes the statement, and after the colon you move into the ident block where you specify whatever you want to in your if block. Now let's say I want to check one more condition, guys. So if x is greater than or equal to 15, if that is not true, I want to check, that is else if. So that is my next condition that I want to check, which is x is equal to 15. Now I am going to print it as it is equal. So now I'll just print it as equal. So, and let me just get the input from the user only using the input method that we have. And I forgot to mention this in the earlier sessions, and you have been following the series. This is how you enter input from the user at runtime. Right, guys, so it's going to ask me to enter a number. So let's say if I write it as 15, the ideal output should be it is equal, but it is showing that it is greater. So let's see what we are doing wrong here. All right, guys, I think I have found the error. So we have two conditions here. So we'll just remove is equal to from here so that it will not be true if we enter 15 again. All right, so it is equal. So that is how you create a if, else, and else if block in Python, guys. These are the conditional statements. This is a very basic example. So it is basically trying to tell you if it's a greater number, or is it equal to the number, or is it not greater or less than the number that you have provided. So this is a very simple example of how we can use if and else if statement or else in Python. Now moving on to the next part where I would just want to show you how we can use nested if statements. All right. So I'll just use this input variable. All right. So this is my input. After that, I have one if condition. So first of all, I want to check if x is greater than 0. Now, and I'll have one more statement, but before that I'll write the penultimate statement which will say print less than 0 or equal to 0. Alright, so if it is greater than 0, now I want to check if x is actually greater than 5. I will print as greater than 5. Else if I want to check if x is less than 5, I will print it as less than 5. Or else if it's greater than 5, it's less than 5, there's only one condition that is left, which is print equal to 5. Now pay attention here, guys. So when I run this, now the first condition is it has to be greater than 0 to move inside this block. So if I write 0 over here, the output will be less than or equal to 0. All right. So in order to move inside this if block, I'll have to give one number that is going to be more than 0. All right. So if I give 2, the ideal output should be less than 5, which is less than 5. Now if I give the value as let's say 16, it is greater than 5. All right. And if I give the value as 5, it will be equal to 5. So this is how if, else if, or nested if works in Python, guys. I have created if statement inside this. And now you can create more nested if here. So if I want to write, let's say if it's greater than 5, I want to check if x is less than 15. So I'll write it as less than 15. Else I'll write it as more than 15. So this is just to show you an example, guys. First it will show me that it is greater than 5, and after that it will show me that it is more than 15. So this is how you create nested if statements in Python, guys. You can use else statement and all those other statements that you want. And I want to show you one more example, guys, where we will have 3 input variables for 3 numbers. So we'll have x is equal to, right? So we'll copy this. So we'll get 3 numbers from the user, and then we are going to check which one is the greatest number, right? So if x is greater than y and x is greater than z, all right, we are going to print x is greatest. All right, guys, so let me write just a number, let's say 10. So x is 10 and y I want to be, let's say 20, and this one is 30. We don't have any output. So when x is not the highest number, we're going to move to the next block and we will check if y is greater than z and y is greater than x, and we will print y is greatest. All right, guys, so same numbers again. So y is 20. We don't have any output again because y is not the greatest. Else we will assume that z is the greatest. 10, 20 and 30. So z is the greatest. And when I run this again, just to double check if I have made it correctly. So let's say I have let's make x is equal to 20, y is 10 and z is 5. So x is the greatest. Then again I want to check if it's working for y as well. So we'll tell y to be 30 and z, let's say 10. So y is the greatest. So that is how you create conditional statements in Python for various purposes. These are very basic examples. All right, guys, let's talk about a few more examples with this. So let's make one program for trying to check if a number is a prime number or not, right? To check if a number is a prime number, first of all we have to make sure that it has to be greater than 0. That's one condition. So let's say x is equal to some number, we'll call it as 10 for now. So if x is not equal to, if x is not equal to 0, then we will move on to the next block, which is if, now we are going to check if x is actually, what is the remainder of x percentile 2. If it is 0, then we know for sure that it is not a prime number. And if it's not, it is a prime number. Alright, guys, since 10 is not a prime number, it is showing that 10 is not a prime number. Let's check for 3, guys. So it is a prime number. Any other prime number that you know of, let's try for 17. It is a prime number. Let's try for 31. Okay, it is a prime number. Let's try for 16. It is not a prime number. And let's try for 13 now. It is a prime number. So this is how you create different conditional statements to check for various tasks that you can perform. And you can actually take input from using the input function over here, where you just enter a number. And after you're done with this, so you enter a number and it will tell you if it's a prime number or not. So that is how easily you can create these conditional statements in Python, guys. And mostly these conditional statements are useful when you're working with the loops, such as for loop and while loop in Python. Now let's also take a look at how we can work with strings while working with the conditional statements. So what we'll do is we'll take a string, or we can take another data type as well. So first of all, we'll just work with strings, and we'll take a look at this name where we'll give the value as Python. Now what we want to check is if particular character, let's say P, in name, then we want to print success, or we will resort to the penultimate statement where we'll just print no result. All right, so we have a success because P is actually in the name Python over here, which we have specified. So this is how we work with the membership operators that we have in Python using conditional statements. Also, we can work with other operators such as identity operators. So let's just check if X is name. So we can just write success, or instead of success, we can create it to the original result, which is true or false. So this is how you can create the conditional statements that we have in Python, guys. And instead of a string, we can use any other data type. So for this, let me just take a list where we have a range from 0 to 100, and we're taking the step as 10. Now I want to check if 50, or let's say if 50 in name, it's going to be true, or if it's not, it's going to be false. So if I want to check for, let's say, 45, it will be false because there is not going to be anything in the name which has a list, and the range is from 0 to 100, and the step is 10, so the values will be 0, 10, 20, 30, 40, and so on. So now that we are done with this session also, let me just give you a quick exercise that you can do to practice this on your own. So what I want you to do is, I want you to write a guessing game program, but for that there is a one prerequisite I want to tell you guys, which is how you import a library or a predefined library in Python. It's nothing but you use the keyword import, and after that you just import random. So what I want to do is I will create a random number generator. So using random integer, I can give values like 0 to 10, like we give in the range function as well. So this is what I want my random range to be, where the random integer will be in the range 0 and 10. So every time I print my number, it will be in the range 0 to 10, but it will be a random number each time I execute it. So what I want you to do is, I want you to create a program where you will take the uh, input from the user, and you will have a random number generator, store it in another variable, and depending upon the choices the user make, I want you to make a guessing game. So as soon as the guess is correct, which means that the guess the user is giving and the random number generated is the same, that is when the user will win the guessing game, and that is the game I want you to make. And there is another program that I want you to make for this exercise, which is write a program to check if a number is a palindrome or not. So these are the two exercises for this session. We're going to talk about loops in Python in this session. So let's just quickly go to the Jupyter notebook and we'll start our session there. So we are in the Jupyter notebook now, and we're going to talk about the loops in Python, guys. So what exactly are loops? Like loops are basically, trying to execute a group of statements that are mentioned in the block for several times. And let's try to understand this with a basic example. Let's suppose you are a software developer and you're required to provide a software module or any module for all the employees in your office. So you must print the details of, your required job is to print the details of the payroll of each employee separately. Now printing the details of the employee will be a tiresome task. Instead, what you can do is use the logic for calculating the details and keep on iterating the same logic statement. This will save your entire time and make your code efficient. Now in this scenario, there will be an iterable object which will have the basic information of an employee, and there'll be a logic behind how to calculate whatever you are trying to let's say you're trying to calculate the tax invoices for each employee that is saved in an iterable object. You will execute the logic behind trying to compute the tax invoice in the loop block. So there are basically two loops that we have in Python, which is for loop and a while loop. So what happens in loop is basically, you start, there is an initialization where you will check if the condition that is mentioned over there is true or not. If it is true, you will move on to the statement or inside the block of the loop. There'll be increment and decrement operators. According to that, the state of the condition will change. And there will come a point where the condition will be false. And that's when the execution will move out of the loop. So let's try to understand the for loop and while loop in Jupyter Notebook, guys. So what we'll do is try to take a look at a few examples and understand how loops work in Python. So first of all, let me just take an object. This will be my iterable object. I'll create a list with a range of 0 to 10. So this is basically my iterable object, which I'm going to use for making a for loop. So to make for loop, you have to use keyword for loop. And now if I want to check for x in, so now comes the part where I'm using the membership operator. So if x in or x is the variable I'm checking, let's say I in x. Now this is the condition that I'm going to test. So if the I, the variable that we have inside the iterable object, like 10 or 15 elements, whatever elements that we have inside the iterable object, it's going to check if it is present inside that object, then only it will move inside the block of the loop. So if that is true, I am going to print I, and now I'll move out of the loop. So this is it, guys. I'll just print, and what is happening here? All right, I'll just write end is equal to this. So now the values are somewhat like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, guys. So this is how you can use a for loop in Python. This is a very basic example. Now let's just say I only want to print the numbers which are divisible by 2. So I'm changing the range. All right. There's one thing I can do. I mean, I can just add a step of 2 over here, but that is very easy. Now I want to use the for loop to do that. So what I'll do is I'll use the if statements, the conditional statements. All right. So this is one way or the other. I'm using the if statement inside a for loop. So I'm going to check if I percentile 2 is equal to 0. So if the remainder is 0 when you divide it by 2, it is but obvious that it is divisible by 2. So I'm going to print I. All right. Else we will break. Okay. So what is going to happen over here? I'll just explain you right now. So the first statement is 0. So now what I will do is I'll make the for loop a little more complicated. So now I'll add more statements in this. So I in x, I want to check if I is less than 15. Then I'll print I, else I is equal to 15. Then I'll print equal to, or let's just keep it as 5. We want so many. And we will do an increment where I will increase the value by 1. All right, guys. So let's try with this. Now we'll have 0, 1, 2, 3, 4, and as soon as it got the value at 5, it is going to print equal to. All right, so this is a very basic example. Now we'll check, or we'll make it a little more complex. So what we'll do is we'll add a few more things. So let's say if I percentile 2 is equal to 0, we want to break, and I plus is equal to 1. There is no print statement, so we'll add a print statement. So we have 0, and all right, so we'll check for something else. First of all, we have to make sure that our I is not equal to 0, or if I is not equal to 0, and if I percentile 2 is equal to 0, then we break. Okay guys, so what happened here is, first of all, there is a for loop here. Now what happens is it moves into the block where it will check if I is not equal to 0. So for 0, and there is a print statement over here, so that is printing all the values that I'm getting, and there is an increment also. So let's say if I divided with 2 and the value is, let's say, 16, so what all values will have? So these are all the values we'll have before we can get to 16 as a reminder. So this is just to make it a little complex, guys. And for a for loop, it's basically, trying to check the condition if it's true, and there are a certain number of iterations that has to be there. So as soon as we reach that condition, or when we reach that condition, it's going to end. So we have an iterable object, it is going to have only 100 elements. So this for loop can only run until I is in X. So for only 100 elements this loop can go on. So that is one limitation with for loop. Now we'll talk about the while loop that we have in Python, guys. So first of all, let's say I is equal to 1. There is a preliminary condition that we have. So while I is less than equal to 10. Now as soon as the condition becomes 11, so as soon as I is equal to 11, the statement or the while loop will move out of the execution. So we'll print I and we'll increment the value by 2. So the output is 13579. As soon as the value became 11, the execution moved out of the while loop block. So the only difference is the while loop will execute until or unless it is meeting the condition or the condition is true. So if I say if I is greater than 0, it's going to keep on forever. I mean, it will execute forever. It will need an external keyboard interrupt, or I'll have to just remove something to make it stop. So that is one condition that you have with while loop, guys. Now I'm going to talk about the control statements that are break, continue, and pass. So for that, we'll just take a look at a for loop, guys. So before that, I'll just take one iterable. So let's say if string, let's see if string is an iterable. All right, so for I in X, if I is equal to S, we will break. Okay, if we'll just do it with I, if it's not, we'll just print I, and I plus is equal to 1. Right, guys, it's taking a bit of time here. Let's see what's wrong. So I'll just stop and run all these cells again. Alright guys, let's see. Okay, we are getting a type error which says can only concatenate string to string. Alright guys, so what we have to do is we'll have to remove this and see what the output is. Okay, so for each I in X, until or unless it's is equal to I, we are moving on with the execution and printing out every character that we have inside the string. So as soon as it encountered I, it just broke the execution and moved out of the loop. So instead of break, we can also use continue, which basically does it's going to skip this iteration where the value of I is equal to I in the string, and that's why it is not there in the output, and will eventually execute all other statements that are already there. Okay, so what I'll do now here is we'll check for pass what exactly it does. So when we have I over here, it does nothing at all. So it is just, a statement where it's the pass statement is a null operation. It basically means that the statement is required syntactically, but you do not wish to execute any command or code. So that is why I just write it there. And now that we are done with this pass statement as well, we'll make one whole program where we'll make use of for loop and nested loops with these break and continue statements. So what we'll do now here is we'll make a half pyramid pattern program, guys. So for that we'll make, let's say, a function, and we'll use the for loop. So for I in range 0 to n, and for j in range 0 to I, plus 1, we will print an asterisk and end it like this. Right guys, so this is how we create a half pyramid pattern. Now what we can do here is we can create other pattern programs using this logic. So and now that we have come to the end of this session guys, where we have actually done nested loops, and we have learned about how we can use the loops in Python with other control statements like break, continue, and pass. So I'm going to give you a simple exercise to practice at home guys. What you have to do is you will have to make pattern programs using this asterisk symbol, where I want you to create a pattern for full pyramid and a downward pyramid program guys. Now I'll just explain you the logic behind this program. So first of all, you have an function over here which I've already explained in the previous session. Now what you want to do here is there is one for loop which is basically in the range 0 to n. So it's going to iterate over this whole block the number of times you have provided n over here, which is 8. So the range is 0 to 8. So the number of times it will execute is 7. As you can see, 1 2 3 4 5 6 7 8. All right, so we're including 0 as well, so it's going to be 8 times the number of times it's going to iterate over the sequence. Now there is another for loop inside this loop where it is in the range of 0 to I plus 1. So for each time, first of all, I is going to be 0 in the first iteration, or instead we can just write it as 1 to I. The output would be same. Or if we write it as 0 to I, let's see what happens. So this is how we can write this program. Now in the next loop, what is happening over here is for each value of I, it is going to print asterisk. All right, and then there is the end of the line. Now to explain this, let me just break it down for you guys. So we have a function over here, and for I in the range 1 to n, so this is going to handle the number of rows that we're going to have, and this j is for the number of columns that we're going to have. So let me just remove a few things to give you a better perspective. So if I don't have these statements, let's see what happens. So right now it looks very haphazard. Nothing is clear guys, so I'll just write it as, let's say, 2. Right, so we need to end the line. That's why we're using the \r, or we can use the \n as well. Right, what is happening here is each value is 2 because we have mentioned the column numbers to be 2. So we'll just make it 3. There'll be 3 outputs here, and if I make it as end is equal to, we're gonna end with a space over here. So this is how it looks like. Now to make it into a pattern, we don't want it to be uniform. We don't want to be in the range 0 to 3. We want it to be in the range 0 to I, and that's how we'll get the pattern for us. So this is when you use \n, when you use \r, the pattern will look something like this. So this is a very simple example guys. I've told you about the exercise that I want you to do. I want you to make a full pyramid pattern. This is a half pyramid pattern. I want you to make a full pyramid pattern. It's going to take 2 patterns over here, and you will have to figure it out by yourself guys. I want you to implement the logic that you find, and by doing that you will be able to build around the learning that you have just learned from this session. This is the model 7 of the Python series, in which we're going to talk about classes and object. So first of all, let me just talk about what exactly is a class, and how we declare it in Python, and what are the different concepts that we have to know while working with the classes in Python. So a class can be seen as a bundle of functionalities, and since everything in Python is treated as an object, a class is also an object. I mean, we can use various methods, functions, data types, etc. in a class and access them using the objects. So let's take it up to Jupyter Notebook guys, and we'll see how we can work with classes and objects. And there's one pressing need to know about scopes and namespaces. So basically a namespace in Python is nothing but, it makes sure that any name that are used in a program are unique and can be used without any conflict. And talking about scopes, Python scope on the other hand can be defined as a region or a block where namespace is directly accessible. So I'll explain that while working on the this session, guys. No worry. So first of all, we have to talk about how we can create a class in Python. So you have to use the prefix, which is a class or a keyword class. After that, you can just mention any name. And first of all, you have to define a init function or an init method. Init method is nothing but, it's like a constructor which gets instantiated each time you create an instance of the class. So it doesn't have to be specified each time, but it's a good practice to make use of init function, because when we create the instance of a class, it actually creates an empty object. So many classes create objects with instances that will have specific initial state. So a class defines a special init method, and when we define the init method, the init method will be automatically invoked when we create the instance of the class. And we can even pass arguments in the init function. So let's just try to understand this with an example. So right now I'm not passing any arguments in the init function. We'll just add one function here, give it some value, let's say function created. Now to access any of the attributes or the references inside my class, I'll have to use instance, or also called as object of this class, by doing this. All right, so this is how you create an instance of a class. Now using this object, I can access all these values. Let's say the show method, right? It has given me an error which says take 0 positional arguments, but 1 was given. So I'll just write self over here. You can write anything over here, it works. Function created, it says. All right, so now we'll pass a few arguments in this. So I'll write name and age as well, let's say, or let's write technology. Yes, I'll remove the past statement here. Wait a second, guys. Yes, now what I'll do is I'll write self dot name is equal to Python, and self dot tech is equal to programming. Now what I can do here is I can access this using this initial instance like this, right? We have an error here, so I'll have to pass some variable here. Now when I access name over here, it's saying Python, and if I access programming or tech, it will show that it is programming. So that is how we work with classes and objects in Python, guys. I have shown you how we can create an init method using parameters and without parameters, and how we can use this self parameter in different functions. It's just an instance of a class. You can write it as self. It doesn't have to be self always, but it's a nice practice to use a predefined name or a constant name in all of your methods. So let's go to the next topic that I want to talk about, which is instance variables and class variables. So this is what I want to talk about next. So I'll just create a class quickly. So let's just say quick class animals, and inside this I have name, I have a value, let's say family, and I'll also write it as place. Now I define the init method where I'll write self and do nothing. Now I create one more function. Let's say I want this function to print. Wait, I'll have to create a few values here. All right, so self dot fatality is equal to fatality, and we want to print the animal is. All right, let's see if we have made any mistakes. So we'll create the instance of the class. All right, so far so good. Now let's try to access show. Okay, so we have to write it as So it's pretty good. So it's showing the animal is highly fatal. So let's name it as snake, uh, reptiles, and place we're gonna call it as swamp. All right, so now name is snake, ob dot family is reptiles, and ob dot place is a swamp. Now out of all these three variables are class variables, and this actually is a instance variable. Now I'll tell you the difference, guys. So if I create another object or instance of the class, okay, I have an error again. So let's say I write it as highly fatal. So when I run this before mentioning anything, it will show us that it is missing one required positional argument, which is fatality. So for each instance, for this instance variable that I've created, I have to give a value. It can be same. I mean, after all, I'm just giving a value to this, but it can be different for, alright guys, I have made a mistake. So instead of OB, I have to write OB1. Now I have to use show. So if I write, let's say, highly fatal, the output is the same. But my point is, for each instance that we create, the instance variable will be different or can be different. So let's say if I create somewhat, let's say kills here, and instead of this self dot kill is equal to kills. Now when I create the instance, I'll have an error, guys. So I'll have to provide a kill value here, which is, let's say, 20, and here as well. So that is how class variables and instance variables are affected or are used in Python, guys. So using ob1 dot, if I check for the family, it will be same, it will be reptiles, because class variables are going to be same for each instance, but instance variables can be different. Now we'll move on to the next one. I'll just show you guys a simple class where we'll make use of all these whatever we have learned. We'll make use of a bigger class where we'll define certain attributes and references. So let's make a zoo, kind of a zoo. So let's just call it as family, which is let's say reptiles and amphibians. All right, now I create a class. Let's call it zoo. Define init self. I'll pass. Now I'll define show, where I'll have self name, and let's also call, let's also name a place here. So self dot name is equal to name, and self dot place is equal to place. Now for I in family, print the family, or not family, we're gonna have to print I, and self dot name and self dot place. Alright guys, so let's just see if it works. Now we create the instance of the class, which is zoo. We have no errors. Now using this object, how many, alright, we'll call show. There's an error, guys. We have to name a snake, let's say, and place we'll call it as swamp. Let's see what the output is. Reptile, snake, swamp, amphibian, snake, swamp. All right. So I'm going to make this for reptiles. Now we'll make another function similar to this, where we just alright guys, there's no error, there is one. So attribute has right, so we have no errors now. So ob dot so amphibians. So for amphibian we'll write it as let's say snake. Alright, we'll have to make a few changes, I think. Now let's see guys, show amp is missing one required argument, which is place. We'll write place as swamp. Right, reptiles, frog, swamp, amphibians, frog, swamp. Alright, so for this also we'll write as snake, and if self dot name is equal to snake. Now let's see what happens guys. Now when I call my show reptile and pass a snake there, let's pass swamp only. So reptiles, frog, swamp, reptiles, snake, swamp. So it's getting reptiles again. There must have been a mistake that I've made over here. Alright, so when I remove this, first of all, I'm getting reptiles, frog, swamp. Now let's see what it happens now. Okay, so I think it's working now. Similarly, we can add one more condition here for if I is equal to reptiles and okay, so when I remove this, it should work. So for amphibians, it will show frog. For reptiles, it will show snake. So that's how we can create apps, or we can add more functions for this. For like for amphibians we have one, for reptiles we have one. We can create for mammals and for birds, for fishes, etc. So now that we have come to the end of the session guys, I want you to make one exercise or do one exercise on this classes and objects. So I want you to create a class where you have different functions to calculate certain arithmetic operations. For example, the first function is calculating the factorial of a number, then the second function is calculating the Armstrong of a number. So you have all these functions inside your class, and you want to actually call these functions in order to perform arithmetic operations. In this session, we're going to talk about the object-oriented programming concepts that we have in Python. So first of all, let me just run you through the concepts that we already have, which is basically nothing but inheritance, encapsulation, data abstraction, and polymorphism. So I'll just quickly tell you what these concepts are all about. So first of all, we have inheritance, guys. In inheritance, it allows us to inherit attributes and methods from the base class, which is also known as the parent class. And this is useful as we can create subclasses and get all of the functionalities from our parent class and reuse the code again and again. Then we can just override and add new functionalities without affecting the parent class. Talking about abstraction. Abstraction is used to simplify complex reality by modeling classes appropriate to the problem. And we will have an abstract class which cannot be instantiated. So This means you cannot create objects or instances of these classes, and it can only be used for inheriting certain functionalities which you call as a base class. So you can inherit functionalities, but at the same time you cannot create an instance of this particular class. So that is how abstraction is done in Python, guys. And for polymorphism is simple, guys. It is basically the concept or the process in which some object or some function can be used in more than one ways. And when it comes to encapsulation is nothing but the process where we are bundling up all the data, or like it is one of the fundamental concepts which describes the idea of wrapping the data together. In plain words, information hiding. So that is encapsulation, what it is all about. So now we'll go to Jupyter Notebook, guys, and we'll try to take a look at all these concepts from programming point of view. So first of all, we're going to start with the, all right, I'll just give it a heading first of all. So the heading will give, concepts. Now the first thing that I want to talk about is inheritance. So when we talk about inheritance, we have to make sure that there are two classes involved. So I'll talk about the simple inheritance first of all. So we'll take one class, name it as a parent class. After that, define a function. Let's say a function where we have some value. So we're going to return, or we'll just print something like this is a parent class function. And after that, we'll have one more class, child. Now to declare this as a derived class, I'll just pass a parent here, and using define, now I'll define a function here again. All right, I'll just make it as function 1, and here again I'll just print something like this is child class function. Now I'll create an instance of this class, child class. All right, so there is no error, guys. Now using the child class function, I'll be able to access the parent class function. So this is what inheritance is all about. I'm able to inherit the properties from the parent class without doing anything. You just have to create the instance, and after using the instance of the child class, I'm able to inherit those properties or able to access those properties. So this is a simple example of simple inheritance where we are doing nothing. We're just checking how inheritance actually works in Python. Now, there can be other types of inheritance as well. So we have a multiple inheritance. So in this, what will happen is we'll have, let's say, there'll be one parent 1, and we'll have a function. Let's say the function is anything. We'll just call it function 1 again. And after this, let's just print a here. Then we'll have a class, another class. We'll have parent 2 here, and we'll define a function 2, and we'll print b here. Now we'll have the child class, guys. So this is where multiple inheritance comes into picture. Now we can get parent 1 and parent 2 here, and we can define one function, let's say show, and we can print a and b. Now what I'll do is I'll create a child class instance again. All right, so nothing is wrong here, everything is running fine. Now using the child class instance, I can call the function 1, function 2, and the child class function as well. So let's just see what happens. We have function 1, we have function 2, and we have child class function as well. So this is how you do multiple inheritance in Python, guys. Now talking about the other type of inheritance, we have a multi-level inheritance, guys. So for that, we can just pass parent 1 over here, and instead of parent 1, we just keep it as parent 2. So now this becomes multi-level inheritance. Now to access right, so we'll have to change a few things here. So we'll have to create one more instance for parent 1 as well, or parent 2, right? So now using the parent 2 object, I can access the parent 1 function, but I'll not be able to access the child class function. Similarly, For child function, I'll be able to inherit all or access all three functions because it is inheriting from both these parents. So this is an example of multi-level inheritance. Now there is one more inheritance that we have, which is hybrid inheritance, which is basically nothing but there'll be two classes inheriting from a single class, and then there'll be one more class involved which will be inheriting from this. And that is all about the inheritance that we have in Python, guys. So next up, I want to talk about polymorphism. So polymorphism in Python is nothing but where we can just add or we can use a function in more than one ways. So let's take a look at polymorphism from a class perspective, where we'll be using inheritance, of course. So let's just create a class. So we'll create a parent class, and inside this I'll have two functions, guys. So first of all, let me just have a function, let's say function 1, and here I just want to print this is a parent class function. And after this we'll have one more function which will be, let's say, show, and here we just want to print b. Alright, now I'll have one derived class which will be child, let's say, and I'm just using these words to be clear on what we are doing here. We can use any words or any names for these classes that you want. Now I'll just pass parent here. So now again I'll use this show or this function show, and here I'll just print C now. So now I'll create the child class instance. So everything is fine now. Now using the child class function, I can access function 1, and when I call this function show, it will override the parent class method. Okay, there is, so it will override the parent class method because we can use it in more than one ways, and that is how we achieve polymorphism in Python using the inheritance, or using the parent and child classes. So that is all about polymorphism in Python. Next up, I want to talk about the encapsulation part. So encapsulation in Python is basically hiding the data, guys. So I'll just tell you how we can create private variables even though we do not have any private keyword in Python. So I'll just create a class, let's say parent. We'll just create a class example now because we don't really need inheritance in this. So we'll define our init function. Here I'll have a name. Now self dot name is equal to name. All right, and I will have one more function which will have, let's say, show. All right, I'll do it like this. Now I want to print this is a private member function. I'll tell you how or why is it private. Now we'll create an instance of this class example. Right, I think there is no error here. There is actually, so we have to mention a name here. So let's just write Python. Now let's see what all are the the functions or the members I can access from this. There's actually none. So if I write it like this, I'll maybe get Python, but we have to write it with an underscore to access that value. Now let's just say I want to access show here. There is an attribute error which says example object has no attribute show. Now you might say that you're writing it somewhat like this, or you forgot to mention the two underscores, that's why it's not showing. So even if I do that, I will still get an attribute error because example object has no attribute show. Because we can make the member functions or member variables private or protected members using the underscore or double underscore naming convention in Python. But to access that, we have one way to do that, that is also called as name mangling. So to do that, I'll just write it as example. Now I'll be able to access it. So this is how we access a private member in Python. So basically this was an example to show you how encapsulation is done in Python. And now I want to talk about the abstraction part. So abstraction in Python is achieved by using or making use of abstract class. Now to make an abstract class in Python, we're going to have to import certain or we have to import from ABC the abstract base class. Now what we'll do here is we'll make a class and we'll derive from the ABC class, which will make it a abstract class. So let's call it as parent. So we are deriving from the ABC class. Now this will become a abstract class, and the first method will become the abstract method. Now to achieve abstraction in Python, what we have to do is we have to create a one function. Let's say self, and we're not going to do anything on this. Let's just pass. Now if I derive from parent and we use same method, we can actually achieve abstraction. So that is how you create, that is how you achieve abstraction, by inheriting from the abstract class or abstract class methods, or overriding the abstract class methods. So we just print something like related to ABC or something, and let's just get one more there. We will use child, or we have to use parent, of course, because we want to inherit from the abstract class, and I'll print XYZ here. Now I'll create the object for child class and an object for the next child class. There is no error. Now using the instance of this child class, I can access function, alright, and using this I can access. So this is how I can do it, and instead of this I can have normal functions as well here, which will inherit the properties. So let's say I have a function intro which just says, or which just prints, this is an abstract class. Alright guys, so I'll just show you what I've done here. So using the child class objects, I'll be able to inherit intro, but I will not be able to make the instance of this abstract class, or I'll not be able to use it using the instance of parent class. So that is why this is an abstract class, and this is how we achieve abstraction in Python, guys. And with this, we have come to the end of the session. Now I'm gonna have to give you an exercise for this. So this is a very basic exercise that I want to give you. I want you to make a program where you will make use of inheritance, where you will take a scenario from a real life scenario. Let's say if you have a school, so you make something like an office as a master parent class, and then make different classes as derived classes, so as to make one whole system where you can use the functionalities, make abstraction layer, and all those sort of things. So that is one exercise that I want to give you for this. So in this session, we're going to be talking about file handling in Python. So we're going to be talking about the various operations that we have in file handling. So we're going to be opening a file from our desktop using the OS module in Python, and then we are going to write into a file, and then we're going to see what are all the operations that we need to perform in order to read from a file, and how many ways we can read from a file, and how to create a new file using Python, and how we can just delete a file using Python. All those operations we're going to perform in this session. But before that, let me just quickly talk about the importance of file handling in Python. There must be a question around you, all of you guys. You must be wondering why there is so much buzz, and why there is so much stress on this very simple thing, which is file handling in Python. Well, for that, let's just try to understand this with an example. Suppose you want your Python script to fetch data from the internet and then process that data that you have just gathered. Now, if that data is small, then this processing can be done every time you run the script. But in case of humongous data, repetitive processing cannot be performed. Hence, the processed data needs to be stored somewhere. So this is where data storage or writing to a file actually comes into the picture. And one thing to note while writing data to a file is that its consistency and integrity should be maintained. And once you have stored your data on a file, now the most important thing is how you're going to retrieve that data, because retrieval is the most important thing. And in computer, it's stored as bits of ones and zeros. And if the retrieval is not done properly, then it becomes completely useless and the data is said to be corrupted. Hence, writing as well as reading is important aspect of file handling in Python, guys. I'll just take you to the Jupyter notebook, guys, and we're gonna resume from there. So the very first thing that you want to do here is you want to open a file. I'll just import OS, and after that I want to open a file. Now to open a file, I'll take one variable, let's say file, and to open it, I'll use the open method. Now inside this, there are going to be two parameters. The first parameter will be the file location, and the second will be the task that you want to perform. Since we're going to open a file and try to read what is written in the file, we are going to write it as R. So if I want to write something or overwrite into a file, I'll write it as W. If I want to append something, I'll write it as A. If I want to create a file, I write it as X. And after that, there has to be a text or a binary number, or the format, it will be text or binary. So by default, it will be text, but we can just write it as RT as well. So we want to read into the text format. And as far as the file location is concerned, let me just go to a location. So this is the location that we have. Inside this, we have a file named series. So let me just copy the file location first. And after that, I'll just write series.txt. All right. So now to check this file, let's just write a few things into this. So this is a demo file, and this is just a document for our testing purpose, so that we are able to understand how we save it. All right, so now we go back to our program here. Now after this, what I want to do is I will read from it, and as soon as I read from it, I will have to close the file as well. So let's just read first. So I'm able to read it. So there are two ways. So right now we have learned how we can read from a file, right? So I'll just close this for now. Okay, so now what I'll do is I will check how many ways we can read from a file. So we'll take one more variable, let's say file1. Now for this, we will open it again. Since we just want to read it, the task will be the same, and we will, instead of read, we'll write it as read line. So let's see what the output is now. Okay, so we have written it as file operation is closed. Now this is a demo file, and this is the purpose of our testing purpose. Is that it? Is that all that was there inside their document? All right, so it's just showing us one line. If I write it as read lines, it will show us the whole document or all the lines that are there inside the document. So that is how you do it. Or we can just write it as read and provide some value for the, or we can write as, let's say 20. So it's going to fetch us all the bytes of data that is there. So let's, for 25, it's going to bring out all those things. So that is how you read from a file, guys. And we'll close this operation as well. Now what I want to do is I want to write into a file, guys. So to do that, we'll make file. Okay, so we'll write it as write into a file. Now to do that, I will make one more variable, let's say file2. Right, I'll copy this. Now instead of wrt, I'll write wt because I want to write into the file. So I'll write file2 dot write, and whatever I want to write over here, it's going to overwrite the content in the current file. So let's say I have overwritten your document, ha ha ha. And after this, let's just check. There's no error, and we will close this operation as well. Now we'll go to the file and let's see what is there. So I have overwritten your document, ha ha ha. So we have overwritten the document using this particular file over here. Now there's one more function we have with this W task over here. So I'll just show you how it is done. So if we actually do not have a file name that does not exist inside there, it's going to create a file there. And let's just write something. I think it worked, and we will close it. So let's see if we are getting any errors. All right, so we have created a new text document and we have also written in. So using this write or the task over here, we have actually created a new file and we have successfully closed that also. Now this is not the exact way to create a file in file handling when we are working in Python. There is of course one more thing that we can do, which is using, right, before that I want to talk about the append function that we have. For the append operation, I'll just write a over here and I'll just write file 3 or file 4 dot write. I hope it does not overwrite everything. Let's see if it works. No errors, so we'll go check the new.txt and I hope it does not overwrite everything. So it has worked. So when you use this append operation, it actually appends the value whatever you are writing inside your document instead of overwriting the whole document. Right, so let's try to check if any of our file or the variables are still operational. So all of those are on a closed file. Now what we'll do is, so now we'll create a new file using the X operation. So for that I'll write file 5 is equal to, copy this, instead of new we'll write as and here we'll write as X and file 5 dot write, we'll write something. This is also a new file and file 5 dot close. So let's go see the demo here. We have a brand new file which says this is also a new file. So this is how easily you can just work with file operations or file handling operations in Python, guys. So now we have actually done all these operations. So we have opened a file, we have closed it, and we have closed all the operations. So now what I want to do is I want to delete some files, guys, or remove some files. We might face a few errors here and there, so just take a look at all those. So I'll import OS, and using os.remove I will delete this file. Let's see if it works. We might face errors here, so let's go check the folder again. So the file is actually missing here, so we have successfully removed that file from over there. There is one more approach to this. You can actually check if the path exists, so that you'll know that file is actually there or not, and then after that, if you're sure, it will remove it. So for that you can just use if os dot path dot exists, the path is this, we will remove it. Okay, so we're gonna have to provide the same path here, else it will show us that file is missing already, or a default message, any message that you want. So when I run this, okay, the file is missing already because we already have deleted that file. So instead of brand new.txt, we will remove new.txt, right? It's showing that file not found. Okay, so now it should work. And all right, so we have deleted all these files. Now let's say I want to delete the last file as well, which is in our folder over there. So instead of new.txt, it will be series.txt. So when I check my folder now, the folder is empty, guys. And now I'll just tell you how you can delete a folder as well. So I'll just close this folder, and now to remove the whole folder, what we have to do is we will have to take a look at this function remove directory, and we provide this path over here. And be very careful when you're using this, because there are chances that you might remove something that you don't want to remove. And there's a bright side to this, which is only you can remove the empty folders, otherwise you will find an error. So when I check this location now, no results found for this location, guys. So that is how you do file handling in Python, guys. So I've shown you how we can create a file and do all these operations on a file. Now that we have come to the end of this session, I want to give you an exercise for this session as well. So for this session, I want you to do something which is basically, you have to write a program where you will have 2 or 3 functions, where you will have a return value in which you have to create a file using the file handling methods, and then store those output, whatever you're getting, inside a file. And that is going to be the exercise for this session, guys. And in the next session, I'm going to work on a few programs which will be the culmination or the collection of all the learning that we have done so far. So we're going to be using classes, objects, we're going to be using the if statements, the conditional statements, the loops that we have learned so far. And we are going to make a bunch of programs that will be very cool to learn as a beginner. And it will help you a lot into, trying to brush up your skills on the basics of Python programming language. So in this session, we are going to make a few Python programs for practice. So first of all, I'm going to start this session with a few pattern programs in Python. So the aim is, or the objective of this session is to make use of all the learning that we have done in the previous sessions and use it to create programs. So the first thing that we would do is use nested for loops to create pattern programs in Python. Now let's just take this variable is equal to, or I'll take it as 20. All right, so if I use a nested for loop inside this for j in range, let's say 0 to k, and I print this value, and let me just print a backslash n, see what the output is. Okay, so it looks somewhat like this, so I'll just make it 5 for now. All right, so my point is, or my objective is, to decrease these values. So to do that, I would write k is equal to k minus 1. All right, I think I know what I'm doing wrong. Okay, so for each value, it is decreasing it the value for this. Now I'll just remove this because we know what's happening. All right, now after this, I'll take another for loop for j in a range 0 to I. Okay, and now I'll just print an asterisk, and n is equal to this. So the output looks something like this. Now from 5, I'll change it to 8. Okay, so now I'll do this, and this is how you create a simple pyramid pattern program in Python, guys. And instead of \n, if you use \r, it would look somewhat more neat over here. Now to make it a little more I mean, you can experiment with the spaces here and there, and you will find different patterns. Now if you want to change the range over here as well, you can change from 8 to 0 with a minus step, and similarly you can go from k to 0 with a minus step, and instead of a subtraction, multiplication here, and you will change it to a reverse pyramid pattern, guys. So this is how you work with pyramid patterns in Python. You can experiment with a lot of these spaces here and there, and you will find a lot of variabilities where you can just experiment with these shapes and sizes. Now we'll move on to the next program that I'm going to make, which is a guessing game in Python. Now for this guessing game, I'm going to make use of two concepts that we learned so far, which is a while loop in Python and conditional statements. So the first thing that we would need is a random number generator. So for that, I'll use a random, and number will be random dot random integer from 0 to, let's say, for now we'll take it as 5, and if, all right, so after this we'll have to take a guess, and it is going to be the input from the user. Now comes the part where I have to define a few conditions. So if guess is equal to number, we will print you win, else we will print keep trying. All right, so let's run this. Okay, now when I enter my guess here, okay, I win because the guess is correct. Now as you can notice, guys, as soon as I give a input over here, the execution stops, which is I'm moving out of the block here. So what I want to do now here is I will put it inside a while loop, but before that I'll just make count is equal to 1, and while count is less than, let's say, 5, and after this count is equal to count plus 1. Okay, so now I'm entering my guess. All right, so this is how you create a guessing game program in Python. Now after I win, I want to break out of the program. All right, so let's just try again. I win. Okay, so now I want to change the range. I'll make it as 10, and instead of 5 tries, I'll only try for 3. So this is as simple as it looks, guys. Okay, so I'll make it a little more, or let's say make it as 10. Right, so I'll have to, I mean, you have to define a few more other things, like if guess has to be less than or is equal to 10, and guess is equal to number, then only we'll check. Or we can make it as a nested loop also. So this is how you create a guessing number game in Python. Now that we're done with this program also, let's move on to the next problem that we have, which is inheritance in Python, guys. So now for this program, what I'll do here, I will create a parent class first of all and define a init function in it with self and let's say name or name and surname. So self dot first is equal to name and self dot last is equal to surname. Now we'll define one more function. So this will be, let's say, show, and in this we will just print self dot first and self dot last. Now when I create the instance of this object here, parent class, I will provide first and last name. Alright, no errors. Now let's see. So this is how I create the instance of the parent class. Now what I'll do here is I'll create one child class and pass parent over here and do nothing for now and create a child class object. And over here I'll just write let's say alright, instead of Harry Kane we'll write Cristiano Ronaldo. Okay, so using that child class object I'm able to access show here. So that is how you use the child class instances to access the parent class methods or member functions. Now you can also add more functions to this. Now let's just add a few more. Alright, so let's try again. So we are getting an attribute error saying child object has no attribute first. So as soon as we add an init method inside this, it's showing that it does not have any attribute. So for that we'll do something like this. Okay guys, and now what I'll do, alright, before that I'll add name and surname here. Now I can just add name and surname here and use the self for country and self dot city is equal to city. Now I define one more function, let's say view, and inside this I'm going to use it to print self dot name self dot, alright, this is going to be self dot first self dot last self dot country and self dot city. Right, so we have init missing two required positional arguments, country and city. So with this I'll have to add Portugal, and for city let's add Madeira. Alright, so now using the child class object I'll be able to get view and show both. So that is how we use inheritance. This is a very basic example. You can just modify itself according to what you need and what you want to do. What I suggest is you can create an employee system where you will have a master class which will have all the details that you want to inherit, such as the confidential details. And then after that you can create abstract classes where you don't want everybody to get the information from, or you can create private variables. Now next up I want to talk about the program to calculate a Fibonacci series in Python. Alright guys, so for Fibonacci series, first of all there has to be a first. Alright, then there will be a second input we will need, and the number of terms that we want inside our series. So we'll print first and last, or we'll print first and second, and is equal to this. Alright, so let's see, first is equal to 10, second is equal to 12, number of terms 10. Alright, so now what I want to do is, while n minus 2 is true, so new is equal to first plus second, and first is equal to second, and second is equal to new. And now we will print new, and end is equal to this. After this, n is equal to n minus 1. Alright, so we enter the first term, the second term, the number of terms, and this is our Fibonacci series, guys. So 1 1, right, one slight change. So 1 1, then the third term is the sum of the first two terms, then subsequently the first two terms are summed to get the next term. So that is how you create a program to calculate the Fibonacci series in Python. Now next up I want to talk about a program where you will check if a number is a palindrome number or not. So for that you will get an input first of all. Let's say int, or we'll have to get it. Alright, I'll just show you what the error will be. Now what I want to do is I want to reverse this using slicing. Right, so there's a type error which says int object is not subscriptable. So instead of int, what we'll do, we will take a list, and let's say, so it is working fine. Now we want to save this into an x1. Right, so now what I want to do is I want to check if x1 is equal to x, then we'll just simply print palindrome, or if it's not, we'll just print not a palindrome. So you can check for this as long as you want. So now what I want to do is I want to do it for a string as well, or I'll just show you another example. Like let's say you have a string and you want to change this or reverse this string. So what you will do is you will write it somewhat like this, and -1 is the step. So that is how you reverse a string. And to reverse a list also, let's say if you have a list with the range 0 to 100 and with the step 10 saved in a variable a, and if you want to just reverse this list, this is the basic example of how you reverse a list using the slicing instead of a reverse method. So now that we are done with all these programs, guys, we have come to the end of this session. And if you have any questions, you can mention them in the comment section below. And you can also tell us in the comments what series we should pick up next. And if you are new here, don't forget to subscribe to Edureka for more exciting tutorials, and also press the bell icon to get the latest updates on Edureka. And this series was specifically for complete beginners who are very new to programming language. That's why it was very basic. And in the future, if we work on something more advanced, somewhat like a data science series or a machine learning series, we'll work on it accordingly. So if you have any questions, you can mention them in the comments. And thank you guys. Have a nice day.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!